dear students of class 11. Welcome you all in my class. I hope all of you are doing well. In the last chapter, we discussed about the subject geography. What is the need to study geography? The relationship of geography with other disciplines and how they are interrelated, different branches of geography, and also we discussed about physical geography and its importance. Now, today we will start with a very new chapter, that is the origin of the earth. Now, there are so many questions that comes to our mind when we look at the sky. From childhood, every one of us has learned a poem that is Twinkle, Twinkle, Little Star, right? Whenever we look at the sky and we look at the stars, so many questions come to our mind that how many stars are there? From where the stars came into existence? What is there in the end of the sky? Can we reach there? From where the earth is formed? From where the other planets has been formed? And what has led to the formation of this universe? What is this universe? What is the solar system? How all of them are formed? So many questions comes to our mind. So in this chapter, we will discuss about all these questions. We will discuss about different theories which will give us an idea that how the earth was formed, how the universe was formed, how it led to the formation of the solar system and the other planets. We will also get an idea about the formation of core, crust and mantle, which is the layer of our earth. So today we will start with the theories which will help us to understand the formation of earth or the origin of the earth. So there were different theories which help us to understand about the origin of the earth. Mainly, we are going to divide it into ancient or early theories and modern theories. In early theories, we will discuss about the gaseous theory or the nebular hypothesis by Kant, the nebular hypothesis by Laplace, the tidal hypothesis by Chamberlain and Moulton, and also about the binary hypothesis. We will also discuss about the modern theory, that is the Big Bang theory. Today in this video, we will discuss about the gaseous hypothesis by Kant. Now, let us understand about the gaseous hypothesis given by Kant. The gaseous hypothesis is also known as the nebular hypothesis, which was first given by Immanuel Kant and later it was again revised by Laplace. So today we will know about the gaseous hypothesis or the nebular hypothesis by Immanuel Kant. The gaseous hypothesis or the nebular hypothesis, which was given by Kant and later it was revised by Laplace, is referred as monistic concept. That means where only one heavenly body is responsible for the formation of the earth. So we are going to discuss about the gaseous hypothesis, which is a monistic concept and one of the most earliest, or we can say the ancient hypothesis, which help us to understand about the origin of the earth. Immanuel Kant in 1755 through his book Our Universal Natural History and Theories of Heaven first discussed his theory of gaseous hypothesis. Now, according to Kant, the gaseous hypothesis of the origin of the Earth is based on the sound principles of Newton's law of gravitation and rotatory motion. So the gaseous hypothesis, which was postulated by Immanuel Kant, he claimed that it was based on the principles of Newton's law of gravitation and rotatory motion. Now, when he gave this hypothesis, he gave some assumption, that there were some assumptions on which the theory was based. Now, let us know about the assumptions on which the theory was based. Let us know about assumptions of the gaseous hypothesis. So the first assumption of the gaseous hypothesis was that there was supernaturally created primordial matter which was scattered in the universe. So what was the first assumption? That there were supernaturally created primordial matter which was scattered in the universe. This was the first assumption. Now, this primordial matter, what was the nature of this primordial matter? This primordial matter was actually a cloud of gas and matter. This was solid, motionless, and cold. Now, why it was motionless and cold? Because the temperature of this primordial matter at that time was near 273 degree Celsius or 0 degree K. That is a reason for which we can say that it was motionless and it was very cold, right? Now, so the first thing that we understood is that there was some primordial matter which was supernaturally created and they were scattered in the universe, and they were solid, motionless and cold, and they are cloud of gas and matter. Now, this primordial matter, according to the assumption of Immanuel Kant, this primordial matter, he assumed that there was collision of particles. So this primordial matters or the particles started colliding. Why? Due to the gravitational force. So due to the mutual gravitational force or mutual gravitational attraction, we can see that the particles, the matter, they started colliding with each other. Now, as those particles will collide with each other, what will happen when the matter will collide? Due to mutual attraction and collision, what is going to happen? it will lead to friction, and friction will generate heat, and heat will rise up the temperature of the matter. So here, due to mutual attraction and collision, we will see that temperature of the matter rises. Along with temperature, we will also see that due to collision, the random motion was generated. And now this random motion and temperature of the matter, which is rising up due to the collision, will lead to rotatory motion. So now, what we can see that in due course, the primordial matter, which was just a cloud of matter and gas, and it was cold, motionless, it will become a vast hot nebula. So it will become a vast hot nebula. Now we can see that in this due course, there will be a change in the state of the primordial matter. What will happen? The state of the primordial matter will change. How it will change? It will change from a solid to a gaseous mass. Now, with increase in temperature, as the temperature is increasing, temperature will increase because the particles will go on colliding with each other. So as the temperature will increase, the speed of the rotatory motion will increase. Of the rotatory motion will also increase, and this will lead to movement of nebula. So the nebula will start spinning around its axis. So the nebula will start spinning and the size of the nebula will expand. So with rise in temperature and the speed of rotatory motion as it is increasing, the nebula will start spinning around its axis and the size will also expand. So we can say that slowly the nebula, the size of the nebula will go on expanding. Now let us see the next assumption. Now, as I said, continuously the temperature is increasing. Size of the nebula is expanding. Now with this we can see that it will produce angular velocity. That means the rotatory speed will become much faster. It will become rapid. And due to this angular velocity, we will see that due to angular velocity, the centrifugal force. Now what is centrifugal force? Centrifugal force means a force that pull things away from the center. Now the centrifugal force will exceed the gravitational force. What is gravitational force? Gravitational force means a force that pull things or attract things towards the center. So we can see that due to the exceed of centrifugal force, now the primordial matter, which has now changed into a gaseous mass, will go on separating rings. So it will lead to separation of irregular rings. So it will lead to separation of irregular rings. So what we can understand is that as the nebula started spinning so rapidly, it started separating irregular rings. Now at the center, this is referred as the sun. This is the residual central mass of the nebula, and this remained as the sun. So this is the sun, and these irregular rings, after condensation, they will go on forming the planets. Now the irregular rings, or we can say the separated rings, caused by the development of core, which led to the formation of planets. So this way according to gaseous hypothesis, in this way the sun and the planets were formed. In the first stage, there was primordial matters which was scattered in the universe, and they are supernaturally formed. This primordial matters, under the influence of gravitational force, or we can say that under the mutual gravitational force, they started colliding with each other. As they started colliding, due to collision, the temperature rise, and as the temperature rise, there was a random motion which was generated, and this random motion generated the rotatory motion. This rotatory motion and rising temperature led to the conversion of the cloud of matter and gas into a vast hot nebula which is spinning around its axis. This cloud of gas and matter, which was cold, motionless, and it was solid, it turned into a gaseous mass, and now it is rotating. You can see that the rotatory motion or the speed started increasing. The temperature increases, the rotatory motion increases, and along with it, the size of the nebula increases. And slowly we will see it will produce angular velocity, and with angular velocity, or due to angular velocity, we will see that the centrifugal force will exceed the gravitational force. It will lead to the separation of irregular rings. The residual matter at the center will remain as the sun, and these irregular rings will later on develop and will form as planets. So this was a hypothesis given by Immanuel Kant. Now this theory of Immanuel Kant was not widely accepted. It was criticized because there were some erroneous in the scientific facts that were given by this theory. Like some of the demerits were like from where First, the generation of angular momentum was not discussed or not explained. Then it did not properly explain the emergence of the primordial matter, like from where the primordial matter came into existence. Then the speed of the sun was lower than the planets. So these are some of the demerits for which this theory was not properly explained. Later on, Laplace revised this theory, and we will also discuss and we will also know about the nebular hypothesis given by Laplace. So in this video, we discussed about the nebular hypothesis or the gaseous hypothesis given by Immanuel Kant. You have to follow the PDF which is given here in the description box. If you have any problem or any suggestion, you can comment in the comment box given below. If you like my video, you can hit on the like button. If you're new to my channel, don't forget to subscribe my channel, and also don't forget to click on the bell icon for further notifications of my upcoming videos. Till then, stay safe and stay at your home. Thank you.